We're going to carry on with our algebra. Today we're going to build on some of the stuff that we did in the first lesson with the expanding and simplifying. We're going to recap some of the notation, and then we're going to see how we can start to use that in combination with numbers in substitution. So let's jump straight into this. So last lesson we looked at some simplifying. That's where, like, you can see I've coloured the terms in there. We can say A's go together, B's go together to collect like terms. We also looked at some brackets, and we said that when you've got something outside, it's like, oh, don't do that, 3x times 2, 3x times 4x. So let's jump straight in with recapping some other stuff that we did last lesson. First of all, let's look at that first one. Let's imagine you have four variables, A and A and A and A together. First thing we said not to do was not to say that is 4 A's. That's when we're adding them together. But we're not adding them together, we're multiplying. And we said whenever we were multiplying them together, we say I've got A multiplied 4 times. The second one we said 2B and 3B. And we say 2 times 3 is 6. And then B times B is B twice B squared. Finally, we have a complex bracket like this. We'd say A times A is A squared, but we've also got the B. A times A is A squared, but we've got 3 of them now because we've got 1 outside and 2 inside. That makes 3 altogether. We've got the C on the end. We've got lots of these to get through, so let's jump straight to the next one. If you've got 4 x's and you divide them by 2, well, 4 divided by 2 is 2. We've got 2 x's. We can write this, if we wanted to, like a fraction. 4x on the top, 2 on the bottom. 4x, 4 divided by 2 is 2. Same thing. We could also say, in the next one, we've got letters and numbers. You could say 12 divided by 3 is 4. You've got 4 A's on the top, 1 A on the bottom. You've got 3 left, like so. If you just see a single term like 5A, just remember that means you've got 5, you've got A, and you're multiplying them together. 5 times A. Here you've got 5, A, and B. When there's no sign, you can assume they're just being multiplied together. Similarly, this is 5 times the whole thing, which gives you 25. 5 times 5, 25 A, B's. So just the numbers with the numbers. This first one here, very important. Similarly, when we've got A squared, it means you've got A twice, and we are multiplying them together. Here, this means you've got A twice, you've got B twice, we're adding them together, but the A's are being multiplied with the A's and the B's with the B's. Similarly, we've got 3 A, 2 A's, 2 B's, we're adding them together, but the B's are times them together, and it's 3 times A times A. Final ones then, we've got A, B, 2 C's. 2 C's are times them together, the A and B are times them together, but they're adding. Remember your BIDMAS, order of operations. Here we've got an A times the B. We've also got A and the C squared, and they're timesing together, combining them like so. Finally, we've got A times B, C squared, and A times the negative D. What am I doing? We're timesing that together, Remember, this one is a minus. So that would give you AB squared. AC squared minus AB. So, that's recapping what we did during the course of last lesson. Let's think a little bit more about this. What is a variable? Here I've got this x. What you need to know about a variable is it varies, it can change. Basically, this can be any value. So this can be any number. It can be 1, 2, 3, 4, 5, 6, so on and so on. It can be any number you could imagine. It can be a decimal. It can be positive. It can be negative. It can be a decimal. It can be a whole number. And it can always change. So it's not like x is the same number in every question. It can be anything at any time. Literally, it varies. It varies from question to question. It's a variable. So when we look at a question like we look at these things here, the A and the B and the C and the D can be any number you can imagine. But sometimes, in certain situations, that's a variable we actually know the value. And we're going to look at an example now. Let's say we had an expression, 3A plus B, 3 apples plus a banana. Think of it like when you go to a shop, okay, you buy 3 apples and a banana, and you don't know the cost. Well, the cost will depend on the price of an apple and the price of a banana. So, the price of each will affect the total. What we can do to find that, remember we were saying, let's think of it as what's the price of an apple and what's the price of a banana. And what we can do, a process in algebra to work this out, is we can do something called substitution. Now think about a substitution in sports. I put a little picture there in case you don't know what a substitution is. It means you take one thing out and you put something else in. Here we're going to do a substitution for letters and numbers. We're going to take out a letter and we're going to put in a number. So let's imagine I just told you, and if you get a question like this, you'll just be told this is the value. There are times when we have to find it for ourselves, but for today we're just going to say I'm just going to tell you. So I'm saying, okay, I'm telling you that A is 6 and B is 4. You go on holiday and I say an apple costs you 6 and a banana costs you 4. So you say, okay, well, we're going to substitute. We're going to take something out first. I'm going to take out the A. I'm removing it from the question because I know that A is worth 6. So anytime I see an A, I'm going to take the A out. I'm going to put a 6 in. But remember to be careful because this 3A means 3 times A. But we now know that A is not A. A is 6. So 3 times 6 is 18. We know that B, because we've been told in the question, is 4. So I can take out the B and put in a 4. I'm going to add on 4. And 18 plus 4 is 22. So if A is 6 and B is 4, the cost would be 22. If I buy 3 of something at $6 each, and 1 of something at $4, my total bill is $22. What about if we use different numbers? Because we know those variables could be anything. What about now if I said A is 4 and B is negative 5? The values change. We say, okay, let's take out the A and let's take out the B. We now know that A is worth 4 and B is worth negative 5. We're adding that on. But we don't have one A, we've got 3 of them. 3 times 4 is 12. When we add a negative, it subtracts. The value is 7. So substitution is just taking out letters, putting in numbers, and working out the total. There's not a huge amount of subtlety to it, because the process is essentially the same as substituting in sport. Take out a letter, put in a number. The thing to be careful of is that you use the notation correctly. Let's imagine we've got a different question. We've got 54 minus 2x. And we said, oh, what would happen if x was 3? So we start off with the question, 54 minus 2x. But we're saying x is no longer x is 3. And remember, it's 2 times 3. 2x is 2 times 3. Well, that would give you 54. If x is 3, we're going to take away 6. and that would give you 48. If x is negative 5, we're going to get a different answer. Now we're saying it's not negative, sorry, it's not x, it's negative 5. And remember, it's multiplied by negative 5. So we'd have 54 again. 2 times negative 5 is minus 10, or negative 10. Two negatives make a positive, so it would be 54 plus 10, so the total would be 64. So depending on the value of the variable will depend on the value of the expression altogether. We can see here that when we put two different numbers in, we get two different answers out. Substitution is the process where you put numbers in and you see what you get out when you change the variable for a number. We can look at this with some different types of notation. Let's start off with this first one. We've got 3a plus 5. So we say, okay, well I know that's going to be 3 times a plus 5. So the first one we're saying is going to be 3 times a plus 5, and a in this case is 2. 3 times 2 is 6, plus 5, the total would be 11. We can see that some things don't change. We're always doing 3 times something plus 5. But we can put a different number in for a. What about if it's negative 3? Well, 3 times negative 3 is negative 9, plus 5 is negative 4. The value of the whole thing changes. If it was a half, we'd put a half in here. 3 times a half is 3 halves, or 1.5, plus 5 would be 6.5. So we can get different values depending on what we put in for a. Here we can say it's 2 minus a, so 2 minus something. We could try it with 2. We could try it with negative 3. We could try it with a half. 2 minus 2 is 0. 2 minus negative 3, minus minus makes a plus. 2 minus a half makes 1.5. So different values depending what we put in. Now when we have a squared, we've got to be very careful. Remember, it's multiply, not add. It's not 2 times a. That is not what it is. It's a times a. So we're timesing the same thing together twice. Here we're saying negative 2 times, positive 2, 2 times 2. Here we're saying negative 3 times negative 3. And here we're saying a half times a half. First one, 2 times 2, I hope is easy for all of us. We can just say 4. Now when we've got two negatives multiplied together, it makes a positive value. Finally, when we've got a half times a half, we get a quarter. Hopefully what you'll notice about all of these is that whether we have negatives or positives or fractions, we always get a positive answer. So anytime you see an a squared on its own, nothing else around it, if you see a squared, it's going to be positive. Finally, we've got a question above, we've got a's and b's. So for the first one, we can see it's going to be a times a and a times b. And we're going to add them together. So we're going to do something times something plus something times b. The first one is going to be 2 times 2 plus 2 times b. Well, 2 times 2 is 4, we can do that. But we don't know what b is yet. So we still end up with just 2b. If we knew what b was, we could figure out what 2b was worth. But we don't, so we can't. And that's okay. Similarly here, we can say it's negative 3 times negative 3 plus negative 3 times b. Negative 3 times negative 3 is positive 9. We've got negative 3 times b, negative 3b. Finally, we've got a half times a half plus a half times b. So it's going to be a quarter plus half of b. So as you can see, you've got lots of different things that we can get out of this expression, or these expressions, sorry, and it depends on what you substitute in, what you put into the question. What you substitute. See that? That's cool, isn't it? We can do this with more than one letter at a time. Here we've got quite a complex expression. A, 2b squared, 3c, and negative d. What about if A was 2, B was 5, C was negative 1, and D was 10? Well, you can see I've written the expression again, and the first thing I'm going to do is just put all the numbers in. What if A was 2? Then we've got 2 lots of B squared, which is 5, and we know we're going to square it. We've also got 3 lots of C. Well, C is negative 1. Notice I'm replacing C and not the 3. Finally, we're going to subtract whatever D is. Well, D is 10. Then we do a little bit of calculation. Well, it's going to be 2 times 5 squared, so that's 2 times 25, 5 times 5, plus 3 times negative 1, and that's negative 3. And then we're going to take away the 10 at the end. You can use your calculator to help you do this if you're struggling at this point. You could say 2 times 25 is 50, 50 minus 3 is 47, minus 10 is 37, and that would give you 74 altogether. You don't like, once you get to this stage here, you can use a calculator to get the final part. So, substitution. Substitution is where you take letters out, you put numbers in, and you work out a final value, a numerical value for your algebra. You need to know what the values are. They'll be given to you in the question today. And you need to make sure you're very careful. I'm just going to go back of some of your key notation. Things like 5a means 5 times a. You know that a squared means a times a, not 2a. So write that again, not 2a, no. And by using numbers and sticking them in, remember it can be any number, so like 6, 4, 4, negative 5. By putting them into an expression, you get different answers out. So we're going to have a go at this today, see how it goes. Just remember to be careful with your notation. Think, are you adding? Are you multiplying? Are you subtracting? Be careful with your positives and negatives, and take the time to write the steps out. Don't try and do it all in one go, because that's when you're going to make a mistake, particularly with the positives and negatives.